So, first of all, the definition. A parallelogram is a quadrilateral. What's a quadrilateral?
A polygon with 4 sides.
Polygon with 4 sides with 2 pairs of parallel sides. So this would be parallelogram TBMD. Now, I can name this. With triangles, the order of the letters didn't matter at all, right? When you're naming a triangle, the order wasn't important. Here, because there's more than 3 letters, we have to name them in such a way that we're going around the parallelogram in consecutive order. So if I start with T and then go to B, where do I have to go next? M and then D. So you could name it something else. You can start anywhere you like, and it doesn't matter whether you go clockwise or counterclockwise. You could call it parallelogram MBTD. Okay, but wherever you start, once you start going in a direction, you have to continue going in that same direction when you name it. Yes, ma'am?
Is that why it's called a parallelogram?
Because the sides are parallel?
That's magical. Real genius.
They worked hard coming up on that name. Huh. The sides are parallel. What should we call it?
Was a gram from something else?
That's a good question. I don't know.
Like a telegram and a parallelogram? No, a parallel telegram? Parallelogram?
No.
Oh my gosh.
But thank you for playing. We have some lovely parting gifts for you.
What?
Never mind.
Oh, I get it now. It took me a second to process.
All right, so what are the properties of parallelograms? Well, if a quadrilateral is a parallelogram, which is something that's surprisingly difficult to say, you really have to kind of chew it. If a parallelogram is if a quadrilateral is a parallelogram, it's a lot of... See what I mean? Then its opposite sides are congruent. And you're like, yeah, they do look congruent. So before we go on, though, and you don't have to copy this down, but please watch and follow along. How do I know that these 2 sides are congruent other than it says so here? Because it says so here is never really a good reason. Yes?
Because segment TB and segment DM wouldn't be parallel if they weren't.
If they weren't what?
Congruent.
Can you see those?
Yeah.
Are they parallel?
No.
Well, you're going to answer my question
Yes.
now. Are they parallel?
Yeah.
Are they congruent?
No.
Okay, so...
The side pieces were parallel.
So say again?
The segments on the side wouldn't be parallel if the top segments aren't congruent.
That's true. Yeah, these 2 couldn't be parallel if the top and bottom one weren't congruent to one another. But can we prove that they're going to have to be congruent to each other? The answer is yes. It's actually fairly easy. Draw on a diagonal. Doesn't matter which one. You don't need to do this. Just watch, okay? So if I draw in this diagonal, I've got 2 triangles now, right?
Yeah.
Can I prove that these 2 triangles are congruent?
Yeah. Yes.
How?
Side.
No and no.
Angle, side, angle.
Angle, side, angle. Please tell me more.
The diagonal is congruent.
Congruent to...
Itself has reflexive properties.
Yes.
And then BMT is congruent to DTM because of alternate interior angles.
Uh-huh.
And then BTM is congruent to TMD because of alternate interior angles.
Exactly right. So those 2 triangles, we could prove them congruent by angle, side, angle. And then by corresponding parts, we would know the top and the bottom sides are congruent to each other and the left and the right are congruent to each other also. Nicely done, by the way. Okay, so that's one property of a parallelogram, is that the opposite sides have got to be congruent to each other. Another one is that if a quadrilateral is a parallelogram, then its opposite angles are congruent. Now, by opposite angles, what would be an example of that? Yes, sir.
Equal TDM.
and angle TBM.
Yeah, or you can just call it angle D and angle B. But yes, exactly right. Why are those congruent? Well, again, go back to this. If I was to draw in a diagonal, can we prove that those two triangles are congruent? Yes, and if they are, then these two angles have to be congruent because those are corresponding parts of congruent triangles. All right, what else do we know? If a quadrilateral is a parallelogram, then its diagonals bisect each other. Okay, well, what does that mean? Well, going back to this again, if I draw in both diagonals, what does it mean for a segment to bisect another one? Yes, Savannah.
They are divided into even groups, or like both sides are congruent.
So they're divided into congruent
Halves.
segments. Okay, they're divided into congruent segments. Well, let's see if we can prove that. So if these two are parallel, we know that this angle is congruent to this angle and this angle is congruent to this angle because when lines are parallel, alternate interior angles are congruent, right? Mm-hmm. And we just said a moment ago that if this is a parallelogram, the opposite sides are congruent. Mm-hmm. So do I know these two triangles are congruent? Yes. So then all the corresponding parts are congruent. Here and here, and here and here. So the diagonals cut each other in half. Okay, they bisect each other. Now, separate question. In this parallelogram, are the two diagonals, TM and BD, the same length? No. You'd be surprised at the number of people who try to tell me that they are. The diagonals aren't the same length in an ordinary parallelogram. Later when we get to the special parallelograms, we'll look at, well, when are they the same? But which one is clearly longer than the other here? BD. BD is longer than TM because of the way that this leans. Okay? If you can think of this as like if you've ever taken a box and opened up the ends and then flattened it, basically that's what's going on. This is partway through the flattening procedure. If we kept flattening it, TM would keep getting shorter and shorter, right? And BD would keep getting longer and longer. Okay? All right. What other properties do we have? The consecutive angles are supplementary. Well, this actually just comes straight from the definition. Consecutive angles, do you know what consecutive means?
They're like reading one.
Yeah, one after another is probably the easiest way to do it. Okay? So consecutive angles would be like, for example, angle T and angle B.
That's just interior, the same angles from
Come on.
Same side interior angles.
Yes, they're just same side interior angles made by parallel lines, so of course they're supplementary. Okay? She eventually got there. All right, let's look at page 2. So, WXYZ is a parallelogram. Find the length of XY and the measure of angle Y. Okay. So, let's start with the length of XY. What segment will XY be the same length as? WZ. The length of WZ is 12A. And you're like, well, that's great, but that's not enough. I'm sure that I need to get a numeric answer for this, not one with a variable in it. So I'm going to have to do something else. Well, what do you notice about the 6A plus 10 and the 8A minus 4? They're equal to each other. So just real quick, 6A plus 10, not plus 18. 6A plus 10 is equal to 8A minus 4. So that'd be 2A is 14, so A is 7. So that's 12 times 7 is
84.
84.
84.
Oh my gosh, bro.
Yes,
12
ma'am.
times 2 is 24.
Anytime in a parallelogram, all the sides will be, not all the sides will be equal.
Which sides? What's the word? Are they next to each other? No.
Across from each other's side.
Almost. Words are hard, I understand. Someone help her out? Yes?
Adjacent.
No, not adjacent.
Opposite.
Opposite.
Oh, the opposite sides are always equal to each other?
Yes.
Okay.
In a parallelogram, the opposite sides are always equal to each other. Yes, ma'am.
How do you know it's a parallelogram?
Because it says WXYZ is a parallelogram.
Yeah, 12 times 7 is 24.
I'm Sammy and I'm really smart.
I thought it said 12 times 2.
It's still not 21.
I said 24 after.
Okay, so now let's see if we can find the measure of angle y. Well, there's nothing here, but what do I know about the measure of angle y? Yes, Marian?
It's supplementary to 9b plus 2,
Yes.
and that 9b plus 2 is supplementary to 18b. Does that say all? Minus 11,
Yeah.
and so you can add 18b.
Okay, wait, hang on. But what is this equal to?
18b minus 11.
Oh, there we go.
Oh.
This is 18b minus 11. Because in a parallelogram, the opposite angles are always going to be congruent to each other. So now, how can we find b?
That's Amanda said.
Okay,
9b plus 2 plus 18b minus 11 equals 180.
yes.
This reminds me of algebra.
Well, this is algebra.
Well,
What is algebra?
it's anything. Oh, I don't know.
What do you mean, what is algebra?
I was going to say
Like,
whenever
what
it has
is
like
it?
a variable in it, it's algebra.
Algebra is a system of mathematics in which you learn to solve equations, primarily.
That is what
Isn't
a
that
math
just
teacher would
it's
say.
all 18B.
I'm sorry? Oh, it's 18b, thank you. So that'll be 27b, won't it? So 27b is equal to 189. So b is 9.
7.
8. 6. 8. 7. It's 7.
It's 7.
7.
If it's going to be a whole number, it's got to be 7 or something that ends in 1 so that we get a 9 when we multiply those together.
How would something ending in 1 do that?
So if it was 11 times 27, oh, sorry, I was thinking ending in 7. My fault. Yeah, the only way to get this to end in 9 is to have something that ends with 7.
And 7 ends with 7.
Yes, it does. All right, moving along.
We never found the angle measure of y.
Oh, we didn't, did we?
It's 115. Yes. I bet
So
you
the
did.
measure of angle y then, what was A?
A was
7?
7.
It's b.
Oh,
18.
B, my fault. So it's 56 minus 4. Is it 52?
It's 115.
That's
It's
18.
18.
Oh, it's 18. I keep doing that. I don't know why.
18 minus 11.
Minus 11, not 4.
You choose the wrong
That's
place.
the
Oh, I totally looked at the wrong place. That would be why. Okay. Whew. So that's 70 plus 56 is 126 minus 11.
115.
Is it 115?
Yes.
It's a good thing we have each other to help each other out here, isn't it? You help me, I help you. It's a beautiful thing. All right.
What?
Isn't that where the bird eats the rhino's back?
Pardon?
Isn't that where the bird eats the bugs off the rhino's
Oh yeah,
back?
like a symbiotic.
A symbiotic relationship,
Yeah.
I know that, guys.
as opposed to what's the one where one feeds on the other?
Parasites.
A parasitic relationship.
Actually?
I know what Terry is now.
She's clearly a symbiote.
Parasites.
All right. Let's take a look at this one. All kinds of information is given. Notice it tells you that this is a parallelogram to start off with.
I thought that was like a square. Like in like rectangle.
And notice it leans to one side, so not a square or a rectangle.
It means parallelogram.
Parallelograms aren't rectangles?
Where does it
A
lead?
rectangle
Not
can
all
be-
parallelograms are rectangles. That is correct.
But all rectangles are parallelograms?
Indeed.
I thought parallelograms had to lean though.
They don't have to. Look at the definition. Turn your page over. Look at the definition. To be a parallelogram, what are the requirements?
A quadrilateral with two pairs of parallel sides.
So does a rectangle fit that?
Yes.
Yes. So a rectangle is a parallelogram. All right. So back to this. The length of LM is 28 inches. The length of LN, that's really hard to put on
I
there.
thought those were angles.
No, that's an L.
Um,
Sorry, but it says inches. How did you think?
I was thinking, and then I went down and it said M and O, and then it had the degree thing, and I was like,
You're very confused?
yeah.
All right, I'm just going to circle this one because there's not an easy way to put it on the diagram. The length of OK is 15 inches. The measure of angle LKN, that's this whole angle. Usually what I do for whole angles like that is I put them outside. Okay. The measure of angle MNO is 62 degrees. And then there's all these things they want you to find. Well, we'll see if we can do them in order. What's the length of KN?
28 inches.
28 inches. That's pretty easy.
Is there ever going to be a time where we have to, like, prove that?
No.
Okay.
It's now a property that you know for parallelograms. So if you know it's a parallelogram, you know that those opposite sides are going to be congruent.
So you could just say because it's a parallelogram.
Right. Now, if we don't know it's a parallelogram, we can't do that.
Okay.
Okay? All right, now we want to find the length of LO.
13 inches.
How did you find that? Yes.
Because LN equals 26 inches, so then you bisect it because they're equal to each other. Both.
They. Who?
Segments.
Which segments?
NO and LO are congruent.
Very
So
good.
you split it in half.
Yep. So each of these are 13 inches.
That was easy.
Well, we're not done yet.
Don't like jinx us.
LMN.
62 degrees. 74 degrees. 74? Oh, I was looking at the wrong one.
Yeah, it's the whole angle, so that's got to be 74 degrees. And then ONK. Oh. What? Did she say oink?
It's
Wait, what?
Okay. So we're looking for this angle right here.
Is it 12?
It is not.
42. Wait, 44.
How are you getting 44? Just curious.
They're supplementary.
They. Who were when you say they are supplementary, I'm like, who's they?
Or MNK and LKN.
Okay.
So,
So if we took 180 minus 74, that's 106. So this whole angle is 106. And so is this one. So then,
106 minus 62.
gives you that this is 44. Jake's on point today. And the crowd goes wild. All right. One more problem. And for this one, grab a sheet of graph paper out of your notebook. You're supposed to have graph paper every single day in this class.
Are we gonna have calculated this
There's a half time.
Yes, we will later on this semester when we get to trigonometry.
I'll bring it tomorrow, Mr. Davis. I
Trigonometry?
promise.
What is trig?
Geom Jan, do you need one? Mary, can you throw me a piece?
Guys don't have any.
That's not really how paper works, but I'll bring you a piece. Just fly it. Make it next to a paper airplane. I'm not
Just
gonna
fly
have-
it.
I'll do it.
Mr. Davis, so I was looking at the rules, and it said quadrilateral, and I was like, it's because there are 4 lateral lines, but then I didn't know where the row comes from, so it should be just quadrilateral.
And quad, how do you name your thigh your quad then? Hell.
Is it a 4?
There's 4 muscles.
Yeah, there's 4 attachments.
Wait, what's a quad?
Your
It's in your
thigh,
Where's your thigh?
right here.
I thought that was just called the thigh.
You just asked what your thigh
The
was.
muscles in the front, Sammy, the muscles in the front of your thigh are your quadriceps.
Do you have your ACL and your hamstring in the
I'm
back?
sorry,
It sounds like a type of dinosaur.
it's not quadrisaur, it's quadriceps.
Like a triceratops.
Top.
Do you have your ACL in your hamstring in the back?
Your knee.
Oh.
Your hamstring is in the back, yes.
Where your ACLs are in the front or the back of your knee?
They're in the front, I believe. Let's see, anterior. I think that's below the knee.
Right here.
I think so, but I'm not positive.
Okay.
I can never remember those. Biology terms just,
I just know the MCL and the ACL are in
yeah, MCL, ACL.
Your MCL's right here.
Wait, ACLs what people tear all the time, right?
People tear all of them. So, all right.
Josh tore his MCL.
So let's take a look at this. So we've got these points, and it tells us that we have a parallelogram ABCD, and it gives us 3 of the 4, but not all of them. And this is not difficult to do if you graph it. If you try to do it just, I'm going to make something up, it doesn't work so well. So B is at -2, 3. And D is at 5, -1. All right, here's the difficulty. There are 2 completely different parallelograms that you could make with those 3 points in them. Okay? The key is in the instructions, it tells you that this is parallelogram. My graph is covering it up, but it tells me that it's A, B, C, D. That tells me the order it needs to go in. Okay, so that means a segment is going to go from A to B, and then it's got to go from B to C, which I don't know where it is yet, and then it's got to go from C to D, and then from D back to A.
Are we gonna have to use the Pythagorean theorem?
Oh, no.
Okay.
No. Fortunately, all we're going to have to do is count.
Yeah.
How do you count across squares?
So what we're going to do is not count diagonally, we're going to count vertically and horizontally.
Oh, I do the slope.
Oh.
Well, not do slope, but like almost like slope.
Yes, very much like slope. And it doesn't really matter which one you choose to do. But you always want to start from the point that these 2 sides have in common. It's always easier if you'll do that. So start from A.
Found it.
Now, since AD is shorter, I'm going to count that one because I'm lazy.
Would it be 1 over 4?
It goes up 1 and to the right 4. So then I want to recreate that up here at the top. I want to go up 1 and to the right 4.
Oh, that was
That way, this is the same length and the same slope. Why is it important that it's the same slope?
Parallel.
So they'll be parallel. If it's not the same slope, it needs to be parallel. And why is it important that they're the same length?
Because they're
Right, it's parallel.
That's one of the properties of a parallelogram. So C is right here at coordinates 2, 4. I'm sorry, go ahead.
Is that it?
That's it.
Oh, no.
And again, the only difficulty in this is that if you don't pay attention to the order of the letters. So I could have drawn a completely different parallelogram, like, let's see, how does that work? If that was
Did you
A,
draw it
B.
from D? Like count the squares to B and then do it.
From A to B and then do from D to C? Yes, it should work out the same way.
Then how did I do it wrong? I got 1 4.
You got 1 4? So from A to B, we go up 1, 2, 3, 4, 5, and to the left 3. So from D, if I go up 5, 1, 2,
Oh,
3,
I had D
4,
at 4.
5, and to the left 3.
Okay.
Okay? Now, the problem is, if you don't pay close attention to the lettering, here's what can happen. Don't worry about trying to copy this down or anything. If you just have these 3 points, you can make a completely, like I said, you can make a completely different parallelogram out of those 3. I'm going to do it in red to show you that it's wrong. If you connect B to D, and then A to D, you could go, that's down 1 and to the right 4, down 1 to the right 4 is here. And you go, okay, C is at -6, 2. Why is that wrong?
Because it didn't go A, B, C, D.
Yeah, it's not A, B, C, D, okay, which is the name. Now, I will say in your book, they almost always give them to you in order. Like they give you A, B, and C and ask you to find D. I'm not so nice.
But these are easy. These aren't too difficult.
Oh, no, it's not hard. You do just have to pay attention. All right, your assignment.
Wait. Oh wait, never mind.
Is it a worksheet? Oh my gosh, Mr. Davis.
It's bookwork, but you've got lots of time.